Is your mobile app really secure? New vulnerabilities pop up every day, and malicious actors look for easy targets on app marketplaces to exploit. Securing your app's valuable IP and data is critical. GuardSquare security solutions are built for developers and protect your app at every stage in the development lifecycle. Multiple layers of protection prevent reverse engineering and automatically detect tampering, making your app a difficult target for attackers. Learn more at securityweekly.com/GuardSquare. Contrast Security enables organizations to secure their applications from development to production. By embedding security sensors within software, Contrast automatically and continuously detects vulnerabilities in both custom and open source code while developers write code, providing them with context-specific how-to-fix guidance for easy and fast remediation. At the same time, by identifying only true vulnerabilities that pose risk and eliminating those that do not, Contrast empowers developers and security teams to prioritize and focus on only those vulnerabilities that matter. Learn how Contrast can help you secure your applications from development through production at securityweekly.com/contrast.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by visiting securityweekly.com/guests and completing the form. We review suggestions monthly and will reach out to you once reviewed. Then you can join us for our next live webcast on December 2nd to see what's under the XDR hood. Visit securityweekly.com/webcasts to save your seat. And don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. And Mr. Kinsella, we have quite a feast of news this week. And one of the things, maybe we should start off on our bounty of bugs and bug bounty practices, because you pulled off 2 articles. I had another one I think that can squeeze into that theme. So Microsoft, Windows, what were they doing around bugs?
It did seem like a pretty busy bounty week, didn't it? So the point of this isn't the Windows Phone itself. I mean, we'll talk about that briefly, but I want to sort of take a step back and look at the overall process going on here. I think that's the interesting part. There was a few Microsoft ones last week, so let me refresh my brain really quickly. This one was, they patched a vulnerability in the Windows installer. For whatever reason, there was some edge cases which the patch didn't catch. So I believe the same researcher went back and found some more issues. But the second time through, here's the interesting part. Instead of notifying Microsoft that, hey, there are still unpatched use cases on that particular security vulnerability, he published it on the internet. And the interesting part of that, not just is that part itself, that always happens a lot, but part of his, when he was actually releasing it, he said, look, Microsoft just isn't paying me what they used to for a vulnerability like this. It's just not worth it for me to go and go to all this work and give it to them when I'm getting, I think for this vulnerability, he would have got $1,000, where in the past he would have got $10,000. So I looked around last week, and I meant to do some more over a weekend, but I ran out of time. But I haven't seen anything official that came out saying that Microsoft was changing their pricing structure or their bounty structure. But so that's interesting in and of itself, that any particular vendor would suddenly be offering less for a bug bounty, right? That by itself would make you think either for some reason they're tight on cash, or there's so many vulnerabilities out there that are being found that they literally can't pay each report that comes in because it's just, or there's some sort of thought process. I'm not saying any one of these is what's going on. I'm just saying what are the particular reasons why you would suddenly start paying a researcher less for something. So what I want to do is contrast that with the next story from Dark Reading. In particular, was talking about GitLab, who is announcing which they are actually raising their bug bounties. And the reason they're raising it, the thought process, which they actually talked through, and this was also Bug Crowd's, Casey Ellis has some comments in here too. But what's going on from that point of view is, as they've gone through time and they've knocked off all the low-hanging fruit to keep a researcher interested, the jackpot which they have to offer to get someone to research, discover a vulnerability, and then report it to them on the bounty program, they have to actually increase that pot of gold is. So that's sort of the leave that there as your two sides of the dichotomy. We got one vendor, doesn't matter who they are, but you got one vendor who is lowering what they're offering for a bug bounty, unknown reason right now, at least for me. And on the other side, you've got a vendor, more than one vendor, that is actually increasing because they want to make sure they're still getting the best people working on their research. So I thought that was sort of two interesting sides of that coin.
It is. And I can add, in my background, I've worked on some large bug bounty program with at the time, about $1 million budget, which, the larger the budget is not how you want to win that type of scenario necessarily. But, there could be also aspects of, you call it double dipping on a vuln, or revisiting a vuln that this is an edge case on something that we know about. So it's good to have the knowledge of the vuln, but should the payout be equivalent or not? And, I'm not saying that's exactly the scenario that you brought up in that first Windows situation, but I can imagine how it could apply to that. It could be similar in that vein. And it also speaks to one of the traps of bug bounty programs in general on the researcher side, is that bounties are based on the risk of what you find. They are not based on the amount of effort you put in. So you could automate something. And even our last segment, Chris was mentioning there's a lot of groups out there that are scanning for known vulns. And so they're getting pretty quick, pretty good at just saying, oh, you're vulnerable. And they can either go down the choice of, we're going to go install some ransomware, crypto mining, et cetera, or awesome, this is now, well, let's get a $1,000 bounty out of it or something out of it for very little effort. So it's that disparity between effort and bounty that can also not feel very good on the researcher side. And that's one of the things that's really tough to navigate, which is also, I think, why you see other organizations also just saying, we're going to increase the bounty because we've hardened our code. So hopefully it's hard, we've gotten rid of some of those attack classes. And we know that with hardened code, it can potentially take more time. More consequential types of vulns also impact, thousands or millions or hundreds of millions of users. So that's also a good reason for us as the organization to know about it and to pay for it, because it's a bug bounty program is often a lot better line item than your fines from the FTC post breach notification.
Yep. And I'd guess there on the GitLab part, they might be increasing their payout, but I'm guessing their overall budget for a year is going down anyways. Just a guess. And I think that's a fair guess with the Microsoft story. That could explain what was going on there. If that's the case, too bad it's not a little bit clearer from whichever side is either griping or paying on that particular topic.
Yeah, I'm not sure. And I'm not sure, especially GitLab, not sure which particular vulns that they've run into recently that have also been helpful to prompt them to increase their bounties. But I do know and pulled out this article that's a little bit older, about 2 weeks old, from some researchers who were exploiting the WebKit's CSP implementation and how they were using that against SSO and OAuth flows, which I thought was pretty interesting. And again, this, I think, ties into the theme you were bringing up, because they start their article off saying, we brought this to WebKit. WebKit said, not a big deal. Or, an attacker has all these other avenues to do the exact same sort of thing, so we're not going to fix it right now, or we're not going to, it's a lower priority. They sat on this for a year, and then they went back and they thought, aha, this CSP implementation in WebKit, the report URI, isn't blinding the full URI path. Normally, CSP report URI is just supposed to return an origin, such as securityweekly.com, rather than the full path like /on-demand. And here I am shilling for our very own podcast. But using that as an example to say, that /on-demand, or as they're pointing out here, in a lot of OAuth token handshakes or dances, there can be sensitive tokens, sensitive information that's in that URL. And so if you can basically craft a CSP violation and trigger that violation, get a auth flow redirect to come back to your reporting endpoint, you can retrieve some sensitive tokens that can do account impersonation. So one other thing that I want to set up is also too, before we dive into a bit more of the discussion, and I give you a chance to talk, John, is that they also there's a lot of user interaction that's necessary here. You have to get your victim to click on the link. You have to get your victim to also interact with the page, because Safari, which is what the WebKit, the browser of what WebKit is powering, is also has this intelligent tracking prevention, was actually preventing the behavior around this type of attack. So there's a lot of interesting things here. That there is an implementation flaw. The flaw itself isn't actually necessarily all that impactful security-wise at a glance, but it's still a bug that should be fixed because it didn't adhere to the CSP spec. But the researchers a year later said, rather than go after WebKit, we're going to go after all these different web properties and point out, basically, you have some flaws in your SSO flows or your OAuth flows, and here's some ways you can harden it. So they collected, I think their number was $100,000 worth of bounties. Yep. Basically using this as an example or as a stepping stone to say, by the way, why aren't you using same site cookie? Why aren't you using these other 2 or 3 recommendations that they have, which are good recommendations in their article? And to my mind, it was a really clever and smart way to say, to get a bounty out of it, rather than just send in a report that says you should be using same site on your cookie. Mm-hmm. Okay, John, I'm going to stop. Your turn.
Okay, start down. You know what's interesting, taking a step back from this for a tiny second, but I think what you were just saying there towards the end is we've seen a few use cases of it this year. There was at least 1, if not 2 stories out of Black Hat this summer where a researcher had found a vuln, but instead of just going and reporting that, they actually walked through how they legitimately made money by doing research, right? So I think one of them was they started with one vuln, then they realized there was a whole area, and they started doing some more research, and they collected more from several vendors, sort of a little similar to this. I think that's it's an interesting form of show and tell to the community, because I suspect there's a lot of people out there who are like, just getting going or interested in bug bounties. And if you're going down that path of research, report, get $500, research, report, get $700. If you're trying to make money at this that way, it's fairly difficult to do. But I think if you take a step back and you're a little more creative about it, are a little more resourceful and thinking outside the box, it shows there's definitely something to be made there. So I think that's, again, it's fairly rare, but I think that's a very interesting takeaway from this year in general. CSP. So this didn't really surprise me. The way I think of CSP is one of the more complex, not super complex, but relatively complex security things for people to set up in a web environment, to set it up correctly, right? There's a lot of sort of moving parts in there. It seems like it's one of those things that we start, you think through where CSP came from. We start off with some simpler things, just like standard cores or, some more simplistic ways of trying to control some of these concepts around cross-site scripting, some of these things we're trying to control, cross domains and stuff. And it seemed like with CSP, they came up with a pretty good control for it, but it's actually too flexible, which means it's more complicated, which means it's harder for developers to understand, which means I bet there's a ton of people out there who are have it configured, misconfigured. So I think that's sort of one of the unfortunate things about this, and that's why not super surprising, unfortunately. I guess, it's I've probably seen 1 or 2 websites where you can quote-unquote lint your CSP, but it feels like we probably need a lot more of that, or that should be part of that toolkit which we have running on our box when we're developing.
Yeah, I was definitely excited when CSP first came out. It seemed like a great idea, but then quickly it's basically unsafe inline, exists on every single website, legacy website out there, even to a degree unsafe eval, which is basically, why did we bother? For newer applications, you can throw the CSP directives on there, and they can help with certain types of attack scenarios. But I think I've come around to the idea that I'd rather just adopt the stronger framework of a React that will be my go-to example all the time, kill that attack class of cross-site scripting or other things. And I guess I've become less excited about CSP, but definitely was excited about this clever use of taking advantage of CSP and demonstrating how OAuth flows can be problems. And here I see part of the solution is to repeat myself, as I often do. Same site cookie does exist, and same site cookie is actually a really great countermeasure against certain types of CSRF scenarios, other things like that, as well as OAuth has a PXE a standard as well that you can adopt, that between same site cookies, PXEs, you can really harden your OAuth flow. And I think that is probably the better take-home message here. And it's not so much these researchers are doing something good about CSP on WebKit. Fine, go fix that bug. But I like this more for elevating awareness around tons of applications out there using these types of authentication flows. Let's harden those flows and modernize those flows, because that's where really consequential problems come in terms of account takeover. So kudos to them for any improvements that they're getting sites to do on that front.
And I think the way you're describing is actually, I'm looking for I'm stumbling for my words in a good way. It's hugely beneficial to our listeners. I think we spend a pretty good amount of time talking about all the sort of the crazy things, like the fuzzing and the rusts and the how do we take care of like these super complex things. But most of, not everyone, but a good portion of our applications out there are web apps. And if you have a firm understanding of some of these relatively basic things, which you can set up without, spending money with a vendor or going to a class or whatever else. So this is something that's within your control, any of our listeners, to work with and understand and improve the security of your product or your application. It could just not be a product. And I think that's important to keep in mind.
Important to keep in mind. It's the type of thing you're not going to necessarily see on a top 10 list. So, we should figure out, what does a good top 10 list mean of use this web technology, apply this to this workflow, some sort of pre-canned threat models, if you will. So maybe that's some homework for, if anybody out there does know of some, absolutely please share, and that will be something for us to develop over time. I'm going to, since we're talking about browsers, I'm going to shift into Microsoft Super Duper Secure Mode for Edge. And I also have to get this out of my head, because I also, every time I hear Edge, I think of WWE Superstar Edge. So all of you wrestling fans out there, big thumbs up to you. But, joking aside, there is, everyone's going to sigh and make their jokes about, yes, super duper secure mode, blah, blah, blah. But if you can get beyond the naming, this is why we don't let engineers name things, the naming of this mode into what they're doing, I think it's actually pretty cool. Because one of the things they come out pretty forcefully saying JIT is responsible for almost half of the critical bugs that are showing up in Chrome. JIT doesn't enable us to turn on certain types of security features that have been around for a long time. And if we disable JIT, we can actually, get rid of a huge attack surface. We can add some better hardening capabilities for the browser. And if we're not going to bother, I shouldn't say not going to bother. We're not going to optimize for arbitrary performance benchmarks. We're going to optimize for usability. And part of that usability comes from the security benefits, as well as just the perception of how do load times look like? How does memory usage look like? And they have some pretty compelling benchmarks themselves, and some experiments where they show that, yes, there are some regressions by getting rid of the just-in-time compiling for JavaScript and being basically as effective as C++ code, or as performant as C++ code. But in other cases, they're also showing we turned off JIT, and look, we're saving on some battery power in some cases. Other cases, the performance has actually improved. So I think overall, I'm a fan of Super Duper Secure Mode, the Edge. But I don't know where you fall on this, John.
I think it's a really interesting idea.
Not a strong endorsement there.
No. It is. Okay. I think it's what's interesting to me is that we've got a JIT in the browser in the first place. So where I was going with this is the second link off that article goes back to Microsoft's. Actually, it's the Edge GitHub site, and they talk about this article from August 4th. Talking about Super Duper Secure Mode. But they were
straight face. Come on.
Yeah, I mean, you have to have fun so kudos for the name.
Yes, totally.
But that sort of talks through some of the stuff in here, like, some of what you were saying. And they talk through sort of the actual, the process of that, a good chunk of that 45%. It's like you fake an object, you get an address of a primitive, or you achieve an arbitrary right, and then you achieve an arbitrary right. It's a fairly standard pattern which goes through. And they talk through the history of where it's coming from. But, it's been very interesting over the last, 10, 15 years to watch sort of how JavaScript in a browser has become this, really a modern browser for most of your single page apps. It's really just it's a container to run JavaScript. It's a container to download JavaScript from a website and run it, right? You're not, the HTML is such a small portion of what's going on. If you think about what any dev team out there is writing, right? The HTML, the CSS, we get that stuff done in a day or so, right? It's everything else around it to get the stuff going. That's where all the code goes and all the development time goes and all the security vulnerabilities come from. So that's really interesting that we've had to stress the importance so much that we put a JIT in place. And keep in mind, a modern browser with the WASM and stuff we've seen, you can run Doom and things like this. So it's not that there's not performance there, but we're always looking for a little bit more. But yeah. So I think, and they actually have a paragraph in here: is JIT worth it? So especially as we get faster machines. My new MacBook is hopefully showing up today. But as these things sort of come along, do we need that extra tiny bit of performance? If you're gaming, probably. But in a lot of cases, yeah, you don't. So if you don't need it, maybe over time we'll get to a point where they'll be able to switch in and out of the super duper secure mode in a more automated fashion. That'd be sort of neat.
Yeah. And I think, thank you for mentioning WebAssembly. We talked about that last week too. So go check out the archives. Check out our discussion last week on WebAssembly and Edge. They are talking about applying these security controls to WebAssembly. So there is a future where WebAssembly can be part of the SDSM. So that's a good thing. Whereas the JIT cannot be. And I think one other comment here, and maybe we've exhausted this topic after this, is that I also am a big fan of deleting code is a great security effort. And disabling JIT is, by deleting code essentially, is a great way to reduce your attack surface. And I'm definitely a fan of not only looking back into the past, but nostalgia can be a golden poison. Or you can look at that with rose-colored glasses and say, at the time, the decision for JIT was good. It was needed. It actually addressed a performance problem. But we live in a modern age where maybe we don't need that anymore and we can get some better security. So that's a good thing. And now we're going to shift from JavaScript and the browser and go deep into hardware and firmware, Mr. Kinsella. I had come across a article about the MediaTek vulnerability. So this was kind of cool, more about the, there was one, I think that their numbers, a third of Android devices are running this particular DSP chip from MediaTek. So there's quite a bit of attack surface out there of people who are exposed. And it's a nice article that once again though goes through some reverse engineering of some firmware, pulls out some C code to look at. So if you're familiar with that, if you don't mind looking at that, take a peek. Otherwise, skip down to sort of the summary section of that article, which just gives a good explanation of what they found, why it was impactful, and what the company did to address it. And in this case, one of the things that stood out to me was the comment that generally device manufacturers don't care about validating their configuration files properly because those configuration files typically aren't available to unprivileged users or they're not misused. But in this case, the attackers were part of their attack chain was putting in a malformed configuration file to get their local privilege exploit, and then basically change some parameters of that DSP to say things like, hey, log all your speech processing and then give it to us, which is basically turning your phone into a bug. So it was one of those things that just stood out as a surprise. There should have maybe been some signing, some integrity checking, or maybe or better validation of that configuration file, or in this case, kind of removing it from production versions, since production versions apparently don't need this. So that was a bit of the takeaway. So I'll either so there's that. I'm not sure how much you looked at that, but I do know you looked into the other hardware story about Switch. So where would you like to take us on this journey?
We'll start with this. We'll start with the MediaTek really briefly for $200, Alex. This interesting write-up. Anytime a write-up's got a good amount of assembly and code, and I'm usually catches my attention. What also caught my attention is, think back over the last 10 years or so. I need to go spend some time on a CVE database. I'm guessing we've seen 5 to 10 MediaTek related vulnerabilities over the last decade. So I think as a security researcher, when I'd see that there is a MediaTek SOC on any type of phone, in this case Android, I would suddenly get pretty interested. So that's neither. Well, it's not great, but I was going to say it's not good or bad. But yeah, it's we talk a lot about, and this isn't in the codec itself. I get that, but we talk a lot about processing input and output, whether it's video or audio, and these more complex things. How do you deal with them? How do you handle them? And this is sort of, again, as I said, it's not in the codec itself, but it's in the configuration in this particular example. And I think one of the other vulnerabilities, it's sort of firing a neuron. I think there was another vulnerability about dev code in prod, which could have, if it was disabled, it would have stopped the vulnerability. Getting back to your comment previously about deleting code, increasing security. Funny that. But let's switch over to the other one. This is a fun one. This is people's long reading, when someone else is decorating the tree or putting up Christmas holiday ornaments or whatever holiday ornaments, and you want to, just sort of kick back with your eggnog and watch from a distance. This one will keep you busy. So, in a nutshell, I've read this and it's complex enough that I'm probably going to butcher myself, so go try not to do that. But on the Nintendo Switch, they are using a SOC, another system on a chip, which is from NVIDIA. And its security processor is of the Tegra architecture in particular, or excuse me, it's a Tegra security, as I told you, I'm going to butcher it. It's a Tegra security processor of the Falcon architecture. I don't have all my links open. There's one I want. So I started in this article in our show notes with a fairly simple overview, just to give people sort of a little more layman's understanding of what's going on in here and what's going on. End of the day, from the high-level architecture, this is really cool, neat research that's not going to allow you to just root your switch in the morning, but it's the results of what these guys have come up with are going to allow other modders and hackers to come up with other cool either mods or plugins or stuff like that for your switch. So that's the TLDR on this. But one of the first links goes to the actual blog post on this. And this is where the fun begins, because this blog post is literally, it's an overview of several years worth of work that these guys have done. And it goes through in detail what the Falcon is, how it works, sort of architectural high-level overviews, which I think in some cases these guys were actually learning and figuring out as they went along. They did get some help from other researchers and some other blogs out there. But yeah, just the amount of stuff that's in here. And then at the end, they're able to actually extract information and extract root keys, which were on the switches, which is what's going to allow those other modders to use those keys and do interesting things with. But this is, you don't want to drink too much of that eggnog when you're reading this, because this will go right through your head and just confuse the living daylights out of you unless you're really into this space. But it's still a pretty fun read with a good number of graphics to sort of get a sense of what's in this chip, right? We talk a lot about like the Intel TPUs or even come on, brain. The AMD TPUs. Like, we talk a lot about these trusted compute units and these secure enclaves, like Apple has them too. Pretty much everyone has them nowadays. I realized over the weekend that I can do a secure boot on my Raspberry Pi. So they're really, pretty much everywhere if you want to enable them and use them. But this gives you, from a graphical point of view, what's inside that thing. What is it actually doing? Because they're almost never just purely security, right? This one's doing HDMI and some video switching and some other stuff. Probably for your copyright control on HDMI, which I don't think anyone's cared about for the last 5 years, but still the vendors put it in. But so this gives you, from a high-level view, what's going on in there, and then digs down through that in, like I said, lots of intimate detail about what this thing is doing and how they were able to actually find some vulnerabilities after writing some code and prying at it. So it's a pretty fun review, a pretty fun blog post, I happen to think.
It is. It's definitely, I'm probably going to finish both Breath of the Wild and Hades before I finish reading through the blog post, but I think all three of them are still entertaining. There was one, I think the other thing that I was going to try to add here too is that you, as you pointed out, this is multiple years and quite a bit of people that are participating in this, and it's definitely a good example of, if we say advanced persistent threat, this is both advanced and persistent in the sense of they've been dedicating many years to this. And the advanced part of this actually is the tooling that they've done. They've created some plugins for Ghidra, which is pretty neat. Now, not to say that this is the same type of APT group that goes into state actors. They're definitely doing this as a hobbyist, as curiosity, and we've seen this within the modding community with PlayStation, for example. And I think they also mentioned the 3DS in here as well. So really neat, really in-depth research. But I'm glad you covered that, John, because I've exhausted my capability to add more.
I'm gearing up for a winter of fun hardware hacking. I have to admit, I'm keeping it as a hobby. I don't want to make it professional, but I'm getting more gear to do hardware hacking. So hopefully, we'll be talking about glitching in the future. One thing I wanted to point out, just what you were just saying, which I think is actually super important. Think back to our interview with Chris in the last half hour, where we were talking about, the difference between just general scanning attacks out there versus, I was using the phrase, if you have a target on your back, right? That's a very different scenario.
Yes.
A lot of people, we always get the question of like, who wants to hack me? Who's coming after me? Dude, it's just some robot that's scanning. And then we talk about, well, I always use that sort of, how would I say, blow off phrase of, if you're one of the ones with a target on your back, you've got a much bigger problem. This is a great blog post of what that ABT is like, right? From the point of view of they will take their time, they will be methodical, they will know your systems probably better than the people who designed some of these chips. They have that level of intimacy, but it took them a long time and lots of work and lots of people to gather it. So take a look over this blog post from that point of view, and then think about if you're working at a large government organization or someone who's doing something with security with high value endpoints, this is the type of thing you have to deal with. There was an article in one of the papers over the weekend it's from Booz Allen I was going to put this into our notes, but I didn't. Booz Allen did a write-up where they are forecasting that the Chinese government is going to start doing more focused attacks, stealing encrypted data and storing it until they're able to decrypt it.
Decrypt
using,
it later, right?
And there's been Wired's run articles in the past saying that NSA is doing this too. But either way, that's a real APT, right? If you're encrypting your data, thinking that's you're good, and you have multiple layers of security, this is a good sort of wake up of what some of the more persistent people out there can go to if they really want your stuff.
Exactly. And a good reason, start that switch to TLS 1.3 and get that forward secrecy. So we'll check back in next year to see what that adoption looks like. Speaking, I'm going to take now as a counterpoint, Mr. Kinsella, I have one last perhaps article to talk about. Just real quick, the GoDaddy breach. This might be the opposite end of the spectrum in terms of advanced threats. And who knows what happened? Maybe it was a misconfiguration, but there was some way that an attacker obtained credentials, gained access to a system, and exposed some things that are kind of eyebrow raising. One is that the credentials were exposed if the time that if you first set up your WordPress admin site and credentials were exposed from an SFTP service. It's not clear if the credentials were directly in plain text or if they were just simply hashed and they were easily cracked. But in either case, having access to credentials is already, by a human is already pretty bad. And that's the type of thing that this day and age should be a lot more secured. So this looks like that aspect of the legacy systems, because I think in there they talk about using a compromised password and unauthorized party access the provisioning system in our legacy code base. So legacy code base strikes again. We can't hand wave them away. We talked with Chris in the last segment, and admittedly, we sort of said that it's pretty hard. That's the tough problem. But maybe we do need some more engineers to come in, do some table flips, and say, we got to get rid of this library. We got to get rid of that library. We got to update this one library and deal with the cascading effects of all of the other dependencies that are now breaking. Because if we don't, these types of things happen.
How do I... there's so many angles you can go with this one. So I'm looking at this from the point of view of someone who built and ran a secure WordPress hosting site. So I know what this is like. I've seen most of these the hosting packages which these guys use, right? So take a step back, and this is an educational moment for listeners. Take a step back and think about. I don't want to say deal with one's names, but there's a bunch of large website hosting vendors out there. GoDaddy's been doing this forever. These are something where you've got 1 million websites. You need to figure out how can you make money off this thing. So you have to have hosting for 1 million websites. You have to have the bandwidth for it. You have to have the software that's stable enough. You have to have customer support. And let's be honest, if it's GoDaddy, your customers are going to be fairly low end. So you have to have more support is the point there. So you have all these type of things you have to keep going, and you need to somehow make money at this. The reason I'm bringing all these things up is where as a result they're not going to invest a lot of money is on securing these things. I can imagine, and this isn't distinct to GoDaddy by any means. At least one of the other hosting packages out there, like software, you can buy software which lets you build your own web hosting company. And multiple of those would have that same unencrypted password, because what's going to happen is, again, the person who calls up, I need help with my website, I can't get in, I can't change, blah, 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 whatever. That's frequently one of the most common things is to allow the CSR, the customer service rep, to be able to say, oh, here's your password. You've told me your secret phrase and everything else. Here's your password, see if that works. Instead of what we should be doing, a reset and all those type of things. So the point being, these are sort of common things. If you're running and the side there is, there's always a balance between security and usability. And the thing is, the people who hear about GoDaddy from the Super Bowl ads aren't probably going to be thinking too much about security, right? So how do you balance and make them secure at the same time? And that's the really tricky part of this. So I think that the long and short of it there is really just sort of put a lot of research and thought into who are you using, why are you using them, and then if you're writing those software packages and you happen to be listening to us, thanks for listening, and make your stuff a little more secure. GoDaddy they used to have a pretty good number of decent coders because they were contributing to CloudStack and some of the other open source packages out there. So I'm not sure if they wrote this one in-house or if they're using something off the shelf. Excuse me, but that's sort of, I don't know, my 10 seconds of fame. I'll shut up now and allow you to move to the next story, Mr. Shima.
No, I think you've brought us near to the end of the show, I think. And so give you one more chance, another 10 seconds if there's something else that you wanted to squeeze in there really quick.
Man, I don't think so. I mentioned the Chinese one. I think I'm good, and I'm just going to allow people to carry on with their day. How about that?
Sounds good. Carry on with the day. We'll know there's no show for us next week, so we're giving John a chance to brush up on his hardware hacking, so he has it, so he can go read out that. But we have also no show next week in order to make time for Security Weekly Unlocked, so you still have a chance to go sign up for that. And with that, I still want to say thank you, everyone. Thank you for John. Thank you for joining me. Thank you, everyone in Discord, for hanging out. We will see you in 2 weeks on Application Security Weekly.